Our lesson for today is about principal roots. So when we say principal roots, it is expressed as nth root of A, where n is the index and A is the radicand. So we have these examples. This one is read as square root, meaning there is invisible 2, or the value of the index here is 2. But we will no longer write 2 here because the symbol itself is understood as square root. Then we have cube root of a number. Then fourth root. And then we have fifth root, sixth root, seventh root, and so on. So, one example is square root of 100. This one is cube root of, let's say, 64. Or we have fourth root of, let's say, 81. And fifth root of 1024. Okay? Or 32. Or fifth root of 32. Let's say this one is fifth root of 32. So, in here, the index is 2 and the radicand is 100. Here, 3 is the index and radicand is 64. Index 4, 81 is the radicand. And here, 5 is the index and 32 is the radicand. What is the principal root of 100? So, we will think of a number that when we multiply it to itself, the answer must be 100. So, it's 10 times 10. And 10 times 10, that is equivalent to 10 squared also in the nth power. So, this can be expressed in the nth power. So, now, 10 squared is equivalent to 100. So, the base here will be the principal root of the number. Because when you expand 10 squared, that is also equivalent to 100. And when you get the square root of 100, that is equivalent to 10. Because the base here is 10. Okay. Another example, square root of 64. What's the principal root? We have 8, because 8 times 8 is 64. Okay. And then we have another example, square root of 81. The square root of 81 is 9. Let's say our given is cube root of 27. We will think of a number that when you multiply it by itself 3 times, that is equivalent to 27. So, 2 times 2 times 2 cannot be. Well, 3 times 3 times 3. Okay, so let's see. 3 times 3 times 3. We have 3 times 3, that is 9 times 3, equivalent to 27. So, in the power of 3, this is 3 cubed. So, the base here is the principal root, which is 3. Okay. So, the answer is 3. So, cube root of 27 is 3. Let us have another example. Let's find the cube root of negative 1 over 27. So, the number to be multiplied by 1 to make it 1 is 1. So, we have 1 over 27 is 3, right? So we have negative 1/3. Okay. And then the other one is also negative 1/3. We multiply it 3 times. Because 1 times 1 times 1 is 1. And 3 times 3 times 3 is 27. Which is also equivalent to negative 1/3 raised to 3. Okay. So since this is also equivalent to negative 1 over 27, so meaning the cube root of negative 1 over 27 is equivalent to 1/3. So the base, this one, is its principal root. But how about if we look for the value or the fourth root of negative 81? What number must be multiplied to itself to make it negative 81? Let's see. Let us find if there is. So let's say 3. Negative 3 times negative 3 times negative 3 times negative 3 because the index is 4. So 3 times 3, that is 9 times 3, 27 times 3 is 81. The answer is positive 81. So negative 3 to the fourth power equals 81. And since negative 81 is not equal to 81, therefore, this has no principal root. Okay. Square root of 121. So the number to be multiplied by itself is 11, right? Because this is equivalent to 11 squared, and 11 squared is 121. So therefore, square root of 121 or the principal root of 121 is 11. Now, let us identify whether the principal root is a rational number or irrational. How to identify if its principal root is a rational number or irrational number? Okay. So, our first example a while ago is square root of 100. So, since the answer of square root of 100 is 10, therefore, square root of 100 is considered as rational number. If the number or the radicand is a perfect nth, okay, perfect nth root, meaning it is considered as rational. But what about if the given, let's say, is square root of 10? Is there any number to be multiplied by itself that is equivalent to 10? Of course, there's none. So therefore, square root of 10 is considered as irrational because 10 is not a perfect square. Okay? Another example, how about if we have cube root of 64? Is there any number to be multiplied by itself 3 times to make it 64? Let's see. Maybe we try 4. 4 times 4 times 4. 4 times 4, 16 times 4 is 64. It's equivalent to 64. So 64 is a perfect cube. So cube root of 64 is considered as rational number. So we will put cube root of 64 here. How about if we have cube root of 15? Is there any number to be multiplied by itself 3 times to make it 15? Of course, there's none. So therefore, cube root of 15 is considered as irrational number. So that's the difference between rational number and irrational number. So we can say, or we can write the given radical in rational if its radicand is a perfect nth or perfect nth root, while irrational if the radicand is not a perfect nth root. So let us have the last example to identify whether rational or irrational. If the given is square root of 324, is 324 a perfect square? So this must be written here, 324. Okay, so how to get the principal root? Number 1, you look at the radicand and index. Okay, the index indicate how many times you multiply the base by itself. So since the index is 2, you think of a number and to be multiplied by itself, and if the answer is equivalent to the radicand, then therefore that number is its principal root. Okay? And to identify again whether it's rational or irrational is by looking at or by identifying whether the given is a perfect square, perfect cube, perfect fourth root, etc. If it's not, we consider the roots or the radical number in irrational category.